All right, let's dive into something pretty wild. We're about to look at a roadmap for a future that's not built on silicon, but on something alive. We're going to break down how the root network of fungi, Mycelium, is being engineered to create everything from compostable packaging to computers that can literally heal themselves. Let's get into it.
Seriously, just think about that for a second. What if your phone could fix its own cracked screen? Or imagine a circuit board that actually regrows its connections after it gets damaged. A device that isn't brittle and disposable, but resilient and alive. You know, it sounds like pure science fiction, but it's a lot closer than you might think.
And that right there is the core idea we're digging into today. The tech we know now is our present, but this organic network, that might just be our future. See, this isn't about just swapping one material for another. It's about a massive shift from building technology to growing it.
So, how in the world do you get from a simple mushroom to a self-healing computer? Well, you have to start at the beginning with the fundamental building block that makes it all possible. The key to absolutely everything is this stuff, mycelium. Now, it's not the mushroom you see on the surface, but the huge hidden root network underneath. You can kind of think of it as nature's own 3D printer and internet rolled into one, a sprawling, intelligent web that you can grow into almost any shape you want. This is our foundation.
So where do you start with a technology this big? You tackle a problem we all see every single day, plastic waste. The first phase is all about using mycelium to create fully biodegradable packaging. Imagine fruit with an edible coating that makes it last longer, or takeout containers that, when you're done, you can just toss in your garden, and they become soil. And check out how it's made. This whole process, it's a single, closed-loop system. It takes an agricultural waste, like sawdust, feeds it to the mycelium, grows it into whatever shape it needs to be, and then finishes the product. Nothing is wasted. It's one biological engine that powers an entire factory. It's pretty brilliant. Okay, so we've replaced plastic. That's big. But the next step is where things get really personal. We're moving from just inert materials to bioactive ones, things designed to work with the human body. This comparison really says it all. A normal Band-Aid is just a piece of plastic you stick on, rip off, and throw away. The Regen Band, though, is totally different. It's a bioactive layer that actually helps your skin heal better, reduces scarring, and then, get this, as your skin recovers, it just dissolves. No waste and no painful ripping off. And this same regenerative idea is being used in high-end cosmetics. Here, mycelium isn't just an ingredient. It's more like an intelligent delivery system. Its natural structure can create this super thin film on your skin that slowly releases compounds to, say, stimulate collagen. Okay, you might want to take a breath because this is where we take a major leap. We've gone from packaging to skincare, now we're jumping into electronics. And this is where the whole idea of a mycelium revolution really starts to click. I mean, this image captures a fundamental problem with all of our tech today. Silicon is brittle. When a circuit breaks, the device is basically dead. It's a one-way street that ends in a giant mountain of e-waste. And this, well, this is the solution. A circuit board that's made from a mycelium substrate. If you actually cut a connection, like you see here, the living network can literally regrow and repair the pathway. All of a sudden, your electronics aren't static, dead objects anymore. They're living systems. The potential for this is just staggering. Think about smart clothing with circuits that can survive going through the wash, or critical parts in a satellite that can repair themselves after getting hit by space debris. This isn't just an upgrade, it's a completely new definition of what reliable even means. So if you can make self-healing wires, what's the next logical step? Well, you build the brain that controls them. You build a computer chip. But this is not like any chip that's ever been made before. Now, to really get why this new chip is so special, we need to understand a concept called neuromorphic computing. Traditional computers follow fixed paths, right? But a neuromorphic system, which is modeled on the human brain, can physically rewire itself. It learns by creating new connections, which is exactly what a living mycelial network does naturally. And that brings us to this, the microchip. It's a true hybrid of biology and electronics. The secret sauce is something called fungal memristive structures. Now that's a mouthful, but all it really means is that the fungal pathways themselves can remember the electrical signals that have passed through them. This lets the chip learn and store information biologically. So this gives you a rough idea of how it all works. At the very bottom, you have the mycelial network. That's the core.
It acts like a network of memoristors, components that physically change to remember the signals they've received. Then you integrate that core with other materials to create a chip that processes information in a totally new way. So, what's the first step for a biological chip? This quote puts it perfectly. The first product is essentially the flash memory of this new world. It's a simple, scalable way to store data biologically, and it's the foundation for all the much more complex chips that are planned to come later. Okay, so let's zoom all the way out. We've seen the pieces, the materials, the medical tech, the circuits, the chip. What's the grand plan? How does this all fit together? The microchip becomes the central brain for a whole new ecosystem of smart devices, a wearable band that monitors your health, or even smart tiles in your walls that learn the acoustics of a room and adapt. All of these devices are interconnected, they're constantly learning, and they're all powered by a living computer. And here we really come full circle. This diagram shows the entire pipeline. It starts with raw biomass that gets grown into materials, which are refined into membranes, which become sensors, which form the chips that ultimately power the devices. It's one single, elegant, waste-free biological engine taking you from soil all the way to smart tech. This quote from the roadmap just perfectly captures the sheer scale of the ambition here. It says this is not a company. It's a civilization-scale materials, electronics, healing, and consciousness platform. The goal isn't just to make a new product. It's to build an entirely new foundation for our technology. This 5-year journey basically maps out the entire story we just went through. Year 1 starts with practical, real-world products like packaging. Year 2 moves into biotech with the Band-Aids. Year 3 introduces the self-healing circuits, which leads to wearables in Year 4, and it all culminates in Year 5 with the flagship product, a fully biological computer. Each step builds on and funds the next one. Which leaves us with this one final, pretty profound question. What happens to our world when our technology is no longer built but grown? When the tools we rely on every day are adaptable, resilient, and fundamentally alive, just like us?